So the first program is using the database stored in the CSV file, which is basically a 7-column file. We need to basically write a program which will be creating the inverted index. Okay, so that was the whole program that we should be writing. So for reading the code, so let me just open the open the notebook to start writing. So so first of all, the file that we will be using is basically a CSV file, which is basically this. So as you can see, the first line is containing this column information, and second line onwards, kind of each line is consisting of one movie information. But note that at some point like this, the seventh column or the last column, which is containing the plot, it is actually considering one new line inside it. That's why the fifth line is containing a part of the plot of the fourth movie, or actually the third movie. So there are so in this kind of a file, using a simple file reading structure where we will be reading the file line by line won't be sufficient, because if we consider each line to be containing one movie information, we will be doing wrong, because as I have said here in this example, here the plot is spreaded across multiple lines. So now we should be using, in Python there are multiple ways of handling this kind of a CSV or TSV file. Two things. One alternative or one basically approach that I have already shared with you guys is using a package called CSV. Another alternative is also possible, which is called pandas. So I hope some of you had already heard of pandas and you have used them. Pandas is basically used for handling panel data. So if we use a CSV reader or a CSV package, then we need to exclude this first line explicitly. But using pandas, we can actually exclude them from our program itself. Now, having said that, let's write the code using pandas. Okay. Now, I have imported the pandas as PDF. Just I will be using an alias PD. NLTK I'll be using for this tokenization and stemming, and from NLTK I will be particularly using this word tokenize function. And porter is I have basically defined an object of the porter stemmer. Let me just execute this cell. Now it is executed. Now the file is stored in this path. So let me just execute this. Now I have to. So now basically the file path variable is containing the file, basically a TSV file, which I should be indexing. That is, I should be using which, or particularly using the plot column of which I should be making the inverted index. Okay. Now let's write the function to do that. Now I have defined, I have written the signature of the function here, def make inverted index, where I will be sending the file path as a parameter. Okay. So first of all, as those of you who already used pandas, you know, the data stored in a pandas or in a file is basically read using frames, particularly data frames. So to do that, to read this file using pandas, what we will be doing is we will be defining a data type or particularly you can say a variable, and PD, which will be basically storing the file as a set of data frames. Now this will be reading the file using pandas, and in DF we will be storing the data frames. Now as I said, we will be storing we will be considering only the plot information, right? So what we will be doing is we will be considering the plot only. Okay. Now this statement will be considering the entire file containing all the column information. This will be selecting only the plot column from the entire data frame. Okay. Now let's declare a dictionary, which will be basically, or let's name it, say, inverted index, which will be basically a dictionary. Let me just write it as well. This is a dictionary with key, the term, and value is basically, we can consider simply a list containing the document frequency of the term and the posting list of the term. This we will be initiating in this function. Okay. All right. So up to now we have passed the file name and we have initialized the data frame. Now what we need to do is, in this data frame, all the movie information are stored one by one, and we need to consider them one after the other. That is one by one. So it is basically containing all the plot information for all the movies. Now we should be considering them one by one sequentially. So say for movie in DF, so if I just want to print the movie name, or say here we are only considering the plot, here if I print movie, so up to this function, if I execute this and if I call this function with the file path that I have set, with the path that we will be using, you will be seeing that each of the, oops, there is an error. I think I have made some mistake here.
So the plot thing.
There is an extra ending bracket here. So you will be seeing the entire file. Oops. So it's actually, I mean, there are many content. That's why it is printing this IOPUB data rate exceeded. All right. So I hope you will be understanding this in a bit with some more into this. So let's declare another thing. So essentially what I'm doing is I'm considering each of the movie plots one after the other. Here in this DF, all the plots are stored. Okay. All right. So now what we need to do is we need to, let's just remove this. The first thing what we need to do is we need to tokenize the plot, isn't it? So let's declare a variable named tokens, where we will be using the word tokenize function, which is defined in NLTK, and we will be passing the movie, basically that movie's plot. Now after executing this, tokens should be containing, for each of the loop execution, tokens should be containing the information, or token should be containing the individual words in that particular movie plot in a list, right? So let's try to see whether we can actually print it or not. I'm not sure whether I'll be getting this error, but let's try anyway. It's actually working. So you can see, so it is actually running. So this is the first movie's plot. A bartender is working at a salon, serving a drink to customers, and so on and so forth. Okay. Now the next thing, so you can see it is still running. Okay, let me just kill it. I have killed the execution. So now the next thing is we need to basically filter out the non-alphanumeric things such as this comma. So if we consider them such as this full stop as well, so these are also considered as individual tokens, which we know is not actually a right thing to do. So the next thing what we need to do is after tokenization, we should be filtering them. So let's just use a list comprehension statement here. Say w dot lower, and we should be also converting them into lowercase as well. For w in tokens, so this is basically this list comprehension will be basically converting them. So let's just try it once again. Tokens say lower, and if I print tokens lower, we will be seeing all of the statements printed in lowercase, all of the tokens printed in lowercase, as you can see. But still this comma, this full stop is still there, right? Now, I have killed the execution. Now what we need to do is we need to exclude them. So one way to exclude them is writing some if condition inside this list comprehension. What we will be writing is if w dot is all num. So if this is true, that is if w is alpha numeric, then only those terms will be considered. Now, if I execute this, you will be seeing that comma and full stop are gone. As you can see, the comma was here, the full stop was there. Those were actually gone. So it is still executing. Let's just kill the execution. Okay, so until now, what I am doing, I have read this file line by line, basically movie by movie. I should not be saying line by line because as we have said, as we have seen, the movie information is spread across multiple lines for some cases. So what I'm doing is I'm reading the movie plots, movie by movie, basically one movie per iteration, and I have tokenized it. I have made it in the lower case. Now we need to stem it, right? We need to apply the stemmer. So let's just apply again. We can use list comprehension here as well. So porter, which I have already defined, porter dot the function is stem. I hope you can remember. Where we'll be passing the w for w in tokens lower. And if I store it here, and if I print the stemmed, we will be getting that you can see bartender has been stemmed. There are so many other words like this. Serves has been stemmed and so on. Okay, so the first step in making the inverted index is basically processing the content. So we have actually done that until now for each of the plots. Note that. Now what we need to do is we need to consider each of these words one by one, right? Each of these words one by one, and we should be making the actual inverted index, isn't it? So an inverted index, let me just give me a couple of seconds to just set up my tab. Yeah. So an inverted index, as we know, is consisting of a word, its document frequency, and its posting list. Until now, what we have done is we have considered for each D in C in the collection, which is the C is the collection. What we have done is basically processed the D of plot. We have done until this, right? So now what we have ended with is basically a set of words basically stored in the stemmed list, which is we should be making we should be putting inside this dictionary, which we have named as inverted index. Now some of you had some confusion regarding whether to do a double pass on the entire collection. So basically reading each files or reading the entire collections twice, once to get a list of W and then to get its TF and the posting list. So I have said you, I have basically I told you that there is an efficient version, there is an efficient way of handling that by using or basically by iterating the entire collection only once. So in this loop, we will be basically doing this. So until now, here we are ended up with the individual words. Now with this individual words, I should be making this inverted index. Now comes the fun part. Now what we need to do is so basically in stem there are individual words stored, right? For stem in stemmed, if I print stem, we know it is basically will be printing the individual tokens, right? Now as we can see, let me just stop the execution. You can see a multiple times occurring, but they are actually in the same document. So for this all three A's, we should be making one entry in the dictionary, in the posting list with A, document frequency 1 and posting lists containing doc ID 1 for all the A's occurring in the first iteration. Note that each iteration in this loop will be basically iterating over the plot of each of the movies, right? Okay, so this is you can understand that this is basically we are considering the individual words. Now we first need to check whether the word is already in the dictionary or not. That is, the word is already in this inverted index or not. Okay, so to do that, let's consider it is a key value pair. Let's consider it as a val inverted index dot get. I hope you know. Yesterday I discussed that what is the difference between using this and using dot get. So using this, we will be getting an error if the word is not present in this inverted index, in this dictionary. But here, if we use this get function, we will be getting a none value returned if the word is or if the key is not present in this dictionary, right? So we should be using this get function here. So if val is equals to none, that means what? Can someone say? Basically, that means the word that I'm basically handling or processing or have processed is still not put into the inverted index. So for that, we need to make a new entry here, right? So for that, what we need to do is we need to we need to put that word, say if the word is say T, if the new word T, we need to put that here along with the document frequency together with the posting list. Now, document frequency when the word has occurred for the first time will be of course 1, right? Because at that point, that is the first time we are occurring, or the word is basically occurring while processing the entire collection. So at that point, the document frequency, this is basically the document frequency, will be set to 1. And here it will be basically the present doc ID which we are processing. Now this thing, as I have said, it is a general practice to start from 0 to basically consider the, say, if there are n number of documents in the collection up to n-1. So basically it is a convention to use an integer to specify to be used as the doc ID. Okay. Now note that here there is no doc ID as such. So for that we need to declare a variable to specify that as well. So doc ID equals to initialize to 0. So when doc ID is 0, that means we are processing the 0th document. So of course the last line of this for loop should be, I hope you can understand, doc ID plus equals to 1. Why? I hope you can understand. So it is inside this for loop. Let me just enable the line number as well. So this will be the last statement. That is, the 0th document plot reading has been completed. Now we will be starting with the doc ID 1. And in the next iteration, it will be incremented by 1 and so on and so forth. Now it's not clear here still. So if the value or the word is not present till now, then what we need to do? We need to basically put that document inside, we need to put that word in the dictionary together with, as we said, we will be using a list here, which will be basically the value. So this will be the key, and this will be the value inside a list, or we can use a set. Basically, this can be used as a set as well. So here, for this example, for this programming, I'll be using a simple list. Now here, for the first time, again I'm repeating, when the term is occurring for the first time, the document frequency or DF should be initialized to 1 at that point, right? Later on, we will be incrementing it. And the doc ID, which is again will be a linked list or a list, which will be containing all the doc IDs in which it is occurring. But when it is occurring for the first time, we should be having a list containing only one item. That is, when T is occurring for the first time, what we need to do is, number 1, initialize INIT, which is a very basic abbreviation of initialize that is popularly used in computer science. Whenever we start our operating system, the first process that starts is called INIT, initiate. Okay, so initialize a list, say L. Second, L will be containing 1, that is the document frequency, and another list containing the present doc ID. Okay, now we will be doing that. Here, if value is not none, value is none, that means it is not present. The word is not in the inverted index. So what we will be doing is we will be first initializing this list. We'll be first initializing this list. So let's say L equals to 1 comma another list. Inside that we will be putting this doc id, because this is the present doc id. Okay, and then what we'll be doing is we'll be putting this list inside basically this dictionary. So put t equals to this L. What does it mean? So basically put in, I have basically put in the inverted index in third bracket the term t equals to L. That means we will be putting that list as a value for this key. The key is basically the newly encountered term. So inverted index, then we should be putting this here. The name of the word is stem equals to the list L, isn't it? Now this is when the term that I am processing is occurring for the first time. Now what if this value is not none? That means we have already encountered the word earlier somewhere, right? Now here else means what we'll be doing is we'll be considering whether we'll be considering those cases as well, in which case the word is occurring in the same document. In that case, we should not be incrementing this document frequency, right? Again, let me rephrase what I have said. So for the else case means the word is already present in this list. For example, this A. If I encounter another A in the same document, right? Then what we should be doing? We should be keeping this document frequency as it is, no updation. We should be keeping this posting list as it is as well, right? Now that's what we will be doing. Else first we will be getting the present list of present this document frequency and posting list pair, which will be basically inverted index stem. Now we know this list will not be empty. It will be containing at least two terms. It will be containing exactly two terms. The first term will be the document frequency, and the second term will be the posting list. Right. Now we need to check whether this present document ID, which I am processing presently, is already present. So let me just write it here. So L0 is basically the document frequency of the word stem, and L1 is basically the posting list of stem, right? Now we need to check whether the present doc ID is already present here or not. That is the first thing we should be doing. If for its simple using a simple statement, we can do that. If doc ID is not in L, basically L1, what we will be doing? This means that I have encountered a word which is already in the inverted index, but it is not from the present document that I am considering. So let me again give you. Yeah, yeah. Sorry, mean, I lost my pen. So here in this case, what is the thing? So A is already present in the dictionary with some document frequency with say 3, and the posting list again a list containing say 1, 4 and say 6. Now again I have encountered A in the fourth document or doc ID 4. Now A is already present. What we will be doing is we'll be checking whether, oops, sorry, not sorry, extremely sorry. So this should be not 4. Say let's say 7. So the doc ID is 7. A is present in 7. Basically, we are processing 7, the doc ID 7, and we have encountered A, right? Now we will be seeing that A is already present in the inverted index. Now what we will be doing is we will be checking whether 7, the present doc ID, is present in this L1 or not. This is L0, and this entire thing is basically the L, which is basically the value, and this is basically the key in the dictionary, in the inverted index. We'll be checking whether it is already present here or not. If it is not present, we'll be appending it, right? And we'll be incrementing the document frequency by 1. That's exactly what we'll be doing. So if doc ID is not there, what we'll be doing is we will be appending the present doc ID into this L1. Sorry, L1 dot append the doc ID, the present doc ID, and we will be incrementing the L0 by 1. Okay. So how many lines have I written? Actually, it's altogether it's 25 lines. Now here, actually, the inverted index creation is completed. That's it. Because whenever we'll be processing, we'll be reading the documents line by line. Basically, we'll be reading the movies one by one, and then each of the movies. So basically, this is movie 1. So let's just print the movie counter as well, so that we can actually understand where we are standing, where exactly we are reading the documents, doc ID. Now, if I execute this, it will be taking, oh, sorry, yeah, there can be some mistake. Name S is not defined. Sorry, I have made some mistake with stem and S. Sorry, this should be stem. You can see we are reading, and it is being read at a very fast pace. Now, of course, considering this as well, it will take around, maybe in my laptop, it will be taking around 20 to 25 minutes. So let's just stop the execution. Let's try with another smaller data set, which I have stored here. So now the new file that we will be processing is basically stored in this file path. Now if I execute this, oops, there is some error. I think, oh, file path is, I think I have made some error in the file path. Oh, I think in the file there was some mistake. Never mind. I have another collection, I think, the toy collection. I don't know what's happening. Let's just stick to the older one, and let's try check whether we are getting the error or not. No, it's actually running for the actual file. I don't know whether I have made some error while making it or not. So let's just do that once again. So this is the entire file, right? So let's only save the first 100 lines from this file. Okay. This is a command to do that. So I'm naming it as a toy file. It's a toy. So here, oh, actually the thing was in those collections in this file, we did not have this column information. Using CSV, it's possible to be read, but using pandas, it's not possible. That's why we're getting that error. Now, if I change this to toy, now it will be basically executing. You can see that it has completed. The execution has completed. Now, if I print the inverted index, sorry, inverted index not defined. Oh, sorry. Another thing that I should be doing is basically here you can see the inverted index is declared inside this function. So it's not actually accessible from outside. So from the last line, we should be returning as a return value from the function. Return inverted index. Now we should be inverted. Let's call it inverted. It is stored. Now if I print the inverted here, note that there is no existence of inverted index here because inverted index is declared in this scope only inside this function and it is not accessible from outside. So that's why what I have done is I have returned that inverted index as a parameter from the function as a return statement, and I have received it in this inverted variable, which is again will be a dictionary. Now let's just print it. You can see the term A is present in 63 documents out of this 67, the total number of documents. And these are the doc IDs in which A has occurred. The next word is bartend, which is present in only one document, and the doc ID is 0. Is present in 52 documents, and these are the doc IDs in which is present. Work is present in 10 documents, and these are the 10 doc IDs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 doc IDs in which word has occurred. Any question up to this?
Sir, I have a problem with how we are ignoring the alphanumerics.
Yeah.
So
Yeah.
when we there while ignoring the alphanumerics, we are just saying if the word is alphanumeric or not.
Right. And
So
we are only considering the alphanumerics. So if there is an apostrophe S, we are basically ignoring it.
if you consider a word like vice dash president,
Yeah.
so that will not be tokenized as vice and then president,
That will
right?
not be tokenized as vice as token. Absolutely correct.
And then
So
that will be
that's a
ignored by
flaw.
this.
That's the flaw of this tokenization. So if I just remove this, in that case, it will be basically considering everything. Let me just try that as well. You can see now we will be seeing A, the word. Then there will be some special characters like say comma. Comma is present in 62 documents, 62 movie plots. So it is
Yes.
basically how we are applying the pre-processing step, right?
I instead used regular expressions in
Yeah,
this.
that's actually fine. That's actually fine. I've just shown you the inverted index creation. How you are pre-processing it, it's up to you. You are free to do anything. I mean, it is just the basic thing. Let me just clear it out. This is not the best solution to to pre-process. I'm just showing how to prepare the inverted index. That's my focus.
Okay.
Okay. Okay, now one major question to you guys. Let's say I have actually indexed the entire collection, and let me just include this so that some of the words are excluded. So you can see it is taking huge time, and it will be actually taking a significant amount of time to make the inverted index. Now, this inverted index creation is a one-time process, isn't it? Because after the inverted index is created, we should be having the freedom of applying the search anytime we like, right? But if I close this terminal, all this inverted index creation, the created inverted index will be gone. Why? Can someone say why?
It will be storing in primary memory.
Correct. It is actually being stored in the primary memory, which is volatile. But we should be having this flexibility that we will be able to store the index in our file as well. So for doing that, what we will be doing is there is a concept called pickling. So using pickle, we can actually store a data set or store an entire you can say a data structure in our memory. So how to actually use this pickle? So basically import pickle, and then you can consider, say, the file in which will be. So basically there are two functions associated with pickling. One is dump the content in a from a variable into a file, or load the data from a file. So if I just write a simple dump data function, which can take two parameters, say that the data and the file in which you want to dump this data, what we will be doing is, say, we'll be starting with the file descriptor. We'll be opening it in the AB mode, which is basically appending in the binary mode. Then pickle dot dump, and then we'll be passing d comma fd, and finally we'll be closing the file descriptor. This will basically dump the content in a file, dump the data structure that we have made in a file, and correspondingly load data, another function, which will be taking a single, just the pickle file as a parameter, pickle file, and say database, or say you can say the again file descriptor equals to let me just copy this pickle file. It's not working. Pickle file, and we'll be starting it in the read mode. And what we'll be doing is we will be reading from the, or loading from the FT, and we'll be storing it in a variable. And finally, we'll be closing that. And from this, we'll be returning the content that we have basically read from the pickle file. Now, this is a function that I hope, I think most of you haven't heard of. So using this pickle, so let's say you are writing your project work and you have written one Python code which is generating a huge data, which is being stored in some particular data structure. Now, if you terminate your code, next time to get back to where you have left your earlier program execution, you need to recompute the entire thing, isn't it? Using pickling, we can start from where we are lefting the job earlier. Using this dump file or dump data or this dump function, and then loading the pickle file which we have made earlier. Is there anyone who have used pickle before? Anyone? Okay, so the file is still, the program is still running, so I will not be able to do that, but still I think we can do that. So let me just stop the execution. So now inverted is containing, let's check the length of inverted. It is containing 2000, only 2000 movies information, or 2200. It's too small, but still it's containing that many words, because as I said, there are caching effect as well. So if I just print, sorry. So if I just print the inverted index, you'll be seeing that these are the words. Now, how to actually store it? So what we'll be doing is we'll be calling this dump data function with the data, which is basically this inverted file, right? And we'll be passing a path, a file path, say dump, so inverted dump dot pickle. The extension is not actually necessary. I'm just giving you. Oops. Oh, actually, I haven't executed this. You can see. Now, if I go to here, you can see inverted dump.pickle is created, which is a binary file. We can't actually, we can't actually store it. I mean, if I open it in the file using some file reader, you'll be seeing it's a binary file. Now to load from where we are leaving, so while searching, what we should be doing is we will be applying this again, inverted, the same, or another variable we should be using, which will be storing the retrieved pickled data, and we will be passing the file path where the pickle is stored. So let me just name it, say D. Now D is exactly the same. I print, you can see it's the same. So using this pickle concept, we will be able to store the inverted index which is created using this indexer function, right? And of course you can understand that indexing is a one-time job, but searching is a multiple time job. So basically after indexing we will be performing this this search multiple times. Okay, so now just to show you the retriever function. So we'll be first taking for the searcher function, for the searching purpose, we'll be taking the query as the input. And the first thing that we should be applying is making it in the lowercase. And we should be applying the same pre-processing step that we have applied here. We should be applying the same pre-processing step here as well. So basically, these two steps or these three steps should be repeated here for the individual words in this queue. So one general practice is defining a general purpose function, process text. Let's name it say process text, which will be taking one parameter which is say text, and which will be basically applying these parameters, these operations on the text. And finally, which will be returning the final process data. So finally, if I say q equals to process text, not analyze text, it's process text, and we should be passing the q. Let's see how this looks like. So if I give the query like say crime in say crime in I don't know, say prison. So let's make it a little bit weird looking. So you can see C is capital, P is capital. Now if I print Q, you'll be seeing that this is actually processed. Now if I give another thing, say Institute of Mental Health, you can see institute has been stemmed of mental all small, health all small. Okay, so up to now we have pre-processed the data. Now we should be basically doing the search. So it's pretty simple. So for Q in Q, so if I just want to print the term, we can do that. But let's consider printing the posting list. Just print basically okay, first of all let's say PL equals to, which will be storing the posting list here, inverted dot get Q, which will be basically taking the posting lists from not the posting list but the DF posting list pair from this, and this will be, I mean, if I print PL, this will be printing that. So you can see none is being printed. That means institute is present in no documents. Mental is also not present in neither of those documents. But off is present in these documents, and health is present in these documents. Basically this document, only one document. Now to get the exact only the posting list, we should be this will be actually an error for the first and second. So what we should be doing is, if PL is not none, can exclude this in as well. Oops, where am I doing this wrong? PL, okay, I think this, yeah, is actually necessary. Sorry for that. So now if I print the word as well, you can see off is present in these documents, health is present in these documents, and there is one overlap. Now we need to get that overlap. For doing that, as I said, we can keep a master list. Let's say all PL initialized with an empty list. Then what we'll be doing is, if this is basically not none, instead of printing, what we'll be doing is we will be appending it to the master list PL. Now if I print the all PL, that is all posting list, it will be containing two items. You can see, sorry, I should be, sorry, one. It is containing two items. One is a list, second is another list. Now what we need to do is, we need to, based on the clause that we want to apply, either union or intersection, we need to do that. So let me write two different functions to do that. Or simply there are multiple ways to do that. Let me just show you some of them. So one way of doing that is using a mapping function called map. Let me just, first write the function intersection. For doing the intersection, which will be easy to understand here because 51 is present here. These two words, basically off and health, is present in 51 doc ID. Set intersection is the function given a list which will be basically providing us with the output, which is basically a set containing the intersection. Now inside, what we'll be providing is a funny thing. I think this you haven't seen earlier. All PL. So now if I print this, you will be seeing only 51. What I am doing here? Here, this function is taking two parameters. One is an iterable data type, and the first is basically a function. Now, this function is converting all the items in this iterable variable, which is basically a list, into a set. This function is doing that. And this star is basically considering, so I hope you know how to handle multiple parameters in a function. So if I want to handle multiple parameters, there is a convention of using this asterisk. So using this asterisk in Python, we can actually handle multiple parameters. So just to show you, I hope you are not being bored. So let me define a function, say f, which is taking, say, a parameter, say star p, print. So for, say, I in p, print I. Let me show you how this will be working. So now if I pass a list containing, say, two item, sorry, or say two item, it will be printing them. If I pass on, say, three items, it will also be printing them. This is the beauty of this asterisk here in Python. Now here, this is actually converting, basically considering these multiple items. So as a result of this, what we are ending up with is a set with multiple items. So it is not bounded. The number of documents, the number of items in this data type is not bounded. So for that, we need to apply this star here. And this intersection is basically, you know the basic understanding of intersection, which is basically considering the intersection of these two sets that is present here we are providing with. Similarly, there is a function called union. Let me just copy it. Union, which will be giving the union of the entire set of all the lists here. So this is the basic way of writing the program. Very basic way of implementing the assignment problem that I have said. The thing, one of the major takeaway message from today's discussion is the use of this pickle. I'm sure you will be finding this very useful later on when we will be doing research or you will be doing your final year project. In case you will be using, in case you you apply Python somewhere, you use Python somewhere, you will be realizing its utility for storing the data structure. As you can understand, the data structure that I am making is taking 40 minutes to make, but to pickle it and unpickle it, it will be done within a second. Basically, after creating this inverted index, as we have seen, it has taken around 40 minutes in our machine, in our systems. So if we just pickle it once, then from the next time onwards, we just need to unpickle it. Basically, we need to load that pickle file, which will be taking less than a second. So we will be able to save some time, some repeated operations as well during the repeated kind of operations that will be needed later on. For example, in this case, this indexing and retrieval case, because indexing is a single time job, one time job. After making this inverted index, we should be able to utilize or use the inverted index for search later on multiple times, right?